Alright, good evening, welcome to
MathyMath number 23.
MathyMath number 23. So this is a neat problem from an old math contest that we saw this morning. The math contest was, what's it called, the IMLM?
Yeah, ML.
And it just asked this number theory question. What is the smallest three-digit integer? Sorry for goofing up the word integer there. Integer that is a multiple of 5 and has exactly 6 divisors. So three-digit integer, multiple of 5 and has exactly 6 divisors.
Alright. So the way you can find the number of divisors for something is like, if you find the number of divisors for 6, which is 2 times 3, you take the powers, they're both 1, and you raise them once, so you have 2 and 2, and then you multiply them. So 4 factors.
So 6 has 4 divisors. And why is that? Why do you raise the powers by 1?
Well, because you can have 0 or 1, 2, or 0 or 1, 3.
Okay.
So
it's actually kind of a neat counting argument.
So we need to have exactly 6. So it means it could either be in the form of prime 1 to the a, or no, prime 1 to the 2, prime 1 to the 1 times prime 2 squared, or prime 1 to the 0 times prime 2 to the 5th.
Interesting.
But this situation really doesn't make no sense. It really doesn't make any sense at all.
Why not?
Because you don't really include this in a prime factorization.
Ah, interesting. So what would prime 1 to the 0 times prime 2 to the 5th really look like instead?
It would look like prime 2 to the 5th.
Okay. Times 1. Okay. Could that make sense?
Well, it could.
Alright. What would it have to be? What would that prime have to be?
It would have to be 5. So it would have to be 5 to the 5th.
Okay.
And 5 to the 4th is, so it's 5, it's 625.
Okay.
5 to the 5th is not a 3-digit number.
Ah, okay. So it doesn't make sense because the prime would have to be 5, and 5 to the 5th is not a 3-digit number. So we can ignore that case safely.
Yeah. So, well, now we can try the 2 options for this case. 5 times prime 2 squared, or prime 1 times 25.
Okay.
Well, this has to be a prime number squared, and the square has to be bigger than 20. Because 5 times 20 is 100.
Mm-hmm.
So 4 is too small. You can't use 5, because we have to have exactly 1 5 here.
Okay.
Can't use 6, and
Why
then
not?
because it's not prime.
Okay. Well, you said you could use 4 then.
You can't use 4
Why not?
because it's too small, and it's not prime either.
It's not prime. Okay.
So this smallest one is 7.
Alright.
So 5 times 49. This is 250 minus 5. Just 245.
Okay.
I'd be surprised if that would be if that's the smallest one.
Might be. I don't know.
So we're gonna have, well, let's have a prime bigger than 4 times 25. A non-5 prime bigger than 4.
Okay.
So 7 again. It's 175.
Interesting.
So this doesn't work. It's too small. It's too big. There.
Too big. Okay.
So this is the smallest one that fits all the requirements.
All right. Cool. Hey, do you think we could real quickly write down the 6 divisors of 175?
Yeah, probably. So you can have. So you can have 7. Make a little divisor chart. Actually. So you can have none of each, so 1. You can have 1 7, or 1 5, 2 5s, a 5 and a 7, and then 2 5s and a 7.
Good. Awesome. Good work. Nice job, man.